Underneath everything we're doing right now is electricity as we program these Arduino or SparkFun boards. So what we're going to do is learn about a little bit of electricity, how it works, and I'm going to show you a little video about how it's created, and then we're going to invert that process and create something cool called a magneto, which sounds like, I think that might have been a Spider-Man villain. All right. So electricity is briefly defined as the flow of an electric charge. We know there's two types, positive and negative. And if you ever messed with a magnet, you know that opposites attract and likes repel. If you ever try to push two magnets together on the positive ends or negative ends, and there's that sort of invisible force field there, that's tied in with how we create electricity. It's really cool stuff. So the way it happens when we generate electricity is we, on that force field, and I'm simplifying things, I'm obviously not an electrical engineer, but we free electrons, and when we harness that and are able to contain them and push them in one direction, that flow is called an electric current, and that's electricity. Now, some things are easier to get electrons from, copper being something that's very easy. The inner rings on copper, the copper atom, they're pretty tightly wound, but there's a 29th one on the outside that 29th electron that's on what's called the valence ring, and that's a little bit easier to be ejected. We can free that, and that's where we get it. So an element's conductivity references how tightly bound those electrons are. So obviously in the previous one, in copper, it's very conductive. Copper, silver, gold, they're usually good conductors. In fact, I think gold is often used in high-end speaker cables because it's such a good conductor of electricity. And then there are things like insulators, glass, rubber, plastic, that prevent the flow of electricity. We use those like on the jumper cables. They do several things. They can prevent interference from coming in. They also prevent us from getting shocked. And then circuits require a continually closed loop. It can be something simply as a wire that's connected end to end, but we're a little more sophisticated than that. We've got quite a number of things connected to it, or we're going to, with our Arduinos, and they can control the flow of electricity throughout our current. Currents can be rather complex, even though they're circular. But the main rule to remember is that when it comes to making circuits, is that they can't have any insulating gaps on them. Talked about we need insulators so we don't get shocked. When we get shocked, what's happening, it's called a short circuit. Electricity is going to take the path of least resistance, just like a lazy student would, and if it's easier to run through you than to complete its originally intended circuit, it's going to do that. So often if you find problems in what you're working with, make sure you don't have a short circuit because you're not completing the path you want the electricity to go through. So a couple important questions. Say we're putting a project together, maybe we're going to build a robot for the robotics club. How much power do you actually need? Well, we know also on the second question what resistors are for and why we need them. But another question would then be, what size do we need? How big of a resistor do we need? Third question, how much power does the LED need? And what if we use too much or too little power? Well, we've talked a little bit about too much power, but what happens when we have too little? Those are some things you can Google, look up the answer for yourself, because now we're going to learn a little bit about how electricity is created and then make that magneto.